Now I am. All right, section 2.4, we're going to do decimals today. To start with, to get our brains working with multiplying and dividing, I've got some multiplication problems up here. None of them are division yet, just multiplication problems. These are integers. And I put them on here so we can remind ourselves what our integer rules are when we multiply versus what we've been doing, which is adding and subtracting. Okay, Rayleigh?
Okay, so like a good way that I like
Mhm.
that like the subtract like the negative. Yeah. So like you would put a bubble and then have the negative sign in it, and then on the other side be positives, and you like cross it out. And so like this one would be a positive number, right? It'd be a negative, but hold on.
So the rule when you multiply and divide is that if you have one negative, your answer is negative. That's not the rule when you add or subtract. Adding and subtracting has more rules. You have to change subtraction to addition. Then you have to check to see if you're actually going to add and join forces or subtract and go to war. It's complicated. All right? Not so complicated when you multiply and divide. One negative makes my answer negative. Two negatives makes my answer positive. That's it. That's the only rule. So I don't know, maybe you're getting confused with the adding and subtracting. Don't go to TikTok for your math advice.
It just pops up on one For You page.
It's like they know. It's like, hey, you're doing math homework, watch this.
Exactly, that's what I'm saying.
The first one, now that we know it's negative, someone tell me what 6 times 8 is.
48.
48. So this is negative 48. It doesn't matter if it's the bigger number that's negative. I'm not going to ask you who wins this battle because we're not going to war. Okay. It doesn't matter if it's the first number, second number, big number, small number. If there's one negative, it's negative. If there are two negatives, it's positive. And so what's 56 divided by 7? 8. So I can write it as positive 8, or we would normally just ignore the plus and just put 8. This means 6 times negative 9. What's 6 times negative 9? Negative 54. Do 6 times 9 and make it negative because there's one negative. What's 72 divided by negative 8? Negative 9. Now this one's interesting. It's got exponents. Can the exponent see the negative? Yes, because what else is there? The parentheses. Yeah, if there's parentheses, they act as a magnifying glass. The exponent can see the negative. So what it's going to do is instead of just repeating the 4, it's going to repeat the negative 4. So if it repeats the negative 4 and makes it look like this, how many negatives are there now?
2.
2. And that makes a positive. And what's 4 times 4?
16.
Okay. How many negatives does this next problem have? 3. So 2 of them can pair up, but a group of 3, you can't have a group of 3 if you're going for partners, right? It's only 2 negatives that make a positive. So even though 2 of them will pair up, there's 1 left over. So remember how it alternates back and forth between odd and even. 1 negative, that's odd, answer is negative. 2 negatives, even, make a positive. 3 negatives, we're back to negative. 4 negatives, make a positive. It just alternates back and forth. This is going to make a negative. What's 3 times 2?
6.
And 6 times 1?
6.
Negative 6. Sure makes you miss the integer chapter that we were just in, right? Remember, to multiply or divide with negatives, we have to count the negatives. And assuming that you guys can count up to probably 3 is the most we had to count to in this, you should be good in tonight's homework. Just have to count. Do I have 1 negative? Make the whole answer negative. Do I have 2 negatives? Make the whole thing positive. Okay, that's what I'm doing. Sorry, either way. All right. Yeah, we just talked about these rules. Multiplying decimals. We're just doing decimals today. Multiplying and dividing them. So multiplying decimals. Ignore the decimal points. Not something you thought you might hear. Ignore them. Pretend they're not there. Then I want you to write the longer number on top. Now, the reason I say the longer number is because the longer number may not always be the larger number. So for example, if I had you multiply 302 times 6, would you write it like this? Or would you write it like this? The first one, of course, yeah. This one just looks more natural to us. And the reason for that is because when I multiply by 6, I'm only going to get one line of numbers, and that's going to be my answer. Whereas if I multiply by 302 on bottom, I got to do 2, then I got to drop a 0, then I have another row, then I have to drop 2 zeros for the 300, and then I have to multiply that, and then I have to add 3 rows together. That's just going to be more work, and I don't want to save myself. I want to save myself that work. I don't want to have to do extra. Okay. Now, you can say, well, Mr. Bright, you put the larger number on top. Well, what about now? What number is larger now? The 6. Do you see why I said put the longer number on top? I still want the 302 to be on top, or the 3.02 to be on top. I want the 6 to be on bottom, but I can't say put the larger number on top, otherwise I'll confuse everybody. With decimals, you can put a decimal right there, and all of a sudden the 3.02 is smaller than 6. So the longer number, or the number that has the most digits, should go on top. Make math simple for yourself, okay? Then we're going to multiply, and we're going to count the negatives to see if our answer is positive or negative. And then one thing we're going to do, I told you to ignore the decimal points. Now we're going to include them back in. I'm going to count how many there are. I'm going to count how many decimal places there are. So count the original decimal places. And I'm going to make sure that my answer has that many. The reason I tell you to ignore the decimal points is because after coming out of the last 2 sections we were in, what did I tell you to do every single time you had decimals? You were adding, subtracting. You had to do what? Line them up. You do not have to line them up when you multiply. What happens is if you force them to line up, sometimes they do. Like, for example, if I had 3.5 plus 2.6, they line themselves up. But what happens is if I have 0.35, maybe get this erased, times 2.6, I'll get people to do that. They'll force the decimals to line up. And then how many decimal places does it look like I have right now? Decimal places. 1, 2, 3, 4. But I just added that 0 myself. So now my answer is going to be all thrown off. Do not line up your decimal points. And to ensure that you don't line them up, I want you to pretend they're not even there. Just ignore them. Okay? If I ignore the decimal points, what's this first number going to say? Yep, 426. What's the second number going to say? And of course, I would write 426 on top because it's larger or longer, right? I'm just going to multiply that. Ignore the decimal points. What's 8 times 6?
48.
48, carry the 4. 8 times 2? 16 plus 4? Should be 20. Close. 8 times 4? 32. 32 plus 2 is 34. Okay, now I have to drop a 0 down. That's because I'm not just multiplying by 7, I'm multiplying by 7D. So I drop that 0 down, scratch these out, but 7 times 6.
42.
Okay, 42. Put the 4 back here. What's 7 times 2? 14 plus 4. 18, carry the 1. 7 times 4 is 28 plus 1 is 29. And I'm going to add these together. I'm going to shrink this down because I wrote too big. What's 8 plus 0? 0 plus 2? 4 plus 8? 1 plus 3 plus 9. Yep, you could, I would just do the 1 and the 9 first. You can make 10, then add 3. And then 1 plus 2. 3. So if I was multiplying 426 times 78, I'd get 33,228. But I wasn't multiplying 426 by 78. I was multiplying 4.26 times 7.8. So how many decimal places do I have in my problem? 3. I need to make sure I have that many in my answer. I don't need to line up the decimals. I just need to use them to know how many there are going to be. Not how many decimal points there's going to be, but how many decimal places there's going to be. So I start at the back side of the problem. If this was my answer, the decimal would be hiding here in the back. So go to where the decimal is. And I want you to count over 3 spots because there's 3 decimal places. And if I count over 3 spots, 1, 2, 3, that's going to put my decimal right there between the 3 and the 2. Make it 33.228. And then let's check. to see if this is positive or negative. How many negative signs do I have? 2. Does that make a positive or negative? Positive, they'll pair up. So my answer is 33.228. There's a lot I have to check, including the negatives. Count the negatives, count the decimal places, multiply like normal. Let's look at another one. If the decimals aren't there, this would just be 25 times 36. And so neither one of those is longer than the other one, so it doesn't really matter which one I write on top and write on bottom. So let's just do 25 times 36. What's 6 times 5? 30. Carry the 3. 6 times 2 plus 3. 15. Okay. Drop down a 0 because now I'm going to multiply by 30. So drop down a 0. What's 3 times 5? Carry the 1. 3 times 2 plus 1. Okay. Add these together. 0, 5 and 5 makes 10. 1, 1, and 7 makes 9. Is my answer positive or negative? Negative. So it looks like negative 900, but I need to go back and count my decimal places. How many total decimal places were in this problem? 2. 1, 2. So I'm going to start on the right side. I'm going to count back 2, 1, 2, and I'm going to put the decimal right there after the 9. Now, if you left your answer like that, I would accept it. However, these zeros are no longer important to us because they come on the, they're at the end of the problem after the decimal. And so I could just write this as negative 9. It'd be like the equivalent of someone saying something costs $9 or $9.00. It's the same. And so I can just say it's negative 9 instead of making it negative 9.00. Really?
So why don't they put that on version?
Because, well, typically things don't cost exactly a certain element. You know what I mean? Like there's like, it's $8.48 or something like that. So,
Why do we have tax?
well, that's how the state gets money. Yep, they use that tax money to, I don't know, make all the improvements you see on the roads and yeah, that's well, taxes are a part of life. Example C, if I ignore the decimal points, this is 215 times 39. So let's write it like that. 215 times 39. What's 9 times 5?
45,
9 times 1
5,
plus 4. 9 times 2 plus 1. Okay. Drop a 0 down because we're multiplying by 30. Scratch these out. What's 3 times 5?
15,
Carry the 1. Put that 1 up here. 3 times 1
3,
plus 1.
4,
3 times 2.
6,
Add these together. 5 and 0 makes 5. What's 3 and 5 make?
9,
8. What's 9 and 4 make?
13,
13. What's 1, 1, and 6 make?
8,
8. Okay, so I got to check a couple things now. I got to see how many decimal places are in this problem. 4 decimal places. So I got to start at the right, and we're going to count over 1, 2, 3, 4. So there should be 4 decimal digits, meaning that my decimal is going to go in front of the 8 to make this 0.8385. Feel free to put a 0 here. I know some people like to do that. It's not necessary, but if you want to, that's fine. And then is my answer going to be positive or negative if I only have one negative? Negative. So negative 0.8385. It'd be really easy to forget to check the negative, wouldn't it? If that's a mistake that you find yourself making, maybe check that right away. Example D. How many negatives do I have? 2 makes a positive. That plus is going to remind me that I've got a positive answer here. That's all it takes. If I ignore the decimal points, what am I multiplying? What is 5 times 5? That's right. Now, how many decimal places does my 25 need? 3, which is interesting. I've only got 2 digits. Well, the same rule applies. Start on the right side, count over 1, 2, and 3. And what should I do in that blank spot right there?
0,
That's right. The number I put in all my blank spots is 0. So this is going to be positive because we've already checked 0.025. So you can put the 0 there if you want to, or you can not put it. It's up to you. This 0 is extremely important. It can't be ignored. because it goes in front of the 2, not behind the 5. So 0.025 positive is my answer. Example E. This is -7 times 3.261. If I ignore the decimal points, it's 3,261 that I'm going to write on top, times 7. I'm ignoring the decimal point for right now. I'll come back and check it later. What's 7 times 1? What's 7 times 6? 7 times 2? 14 plus 4? 7 times 3? Plus 1. Okay. If it were 3,261 times 7, that'd be my answer. But it was 3.2617. So I'm going to take the decimal point and I'm going to move it over how many times? 3. That's going to put it right there. Is my answer positive or negative? Negative 22.827. And finally, example F. Can the exponent see that the negative's there? Yes, because there are what? Parentheses there. So because the parentheses are there, it sees the negative, not just the 4 or 0.4. So it's going to make this negative 0.4 times negative 0.4. I'm repeating the negative because the exponent sees it, times negative 0.4. So that's essentially the same problem here. So if I ignore the decimal places for the next decimal points, this is just 4 times 4 times 4. So what's 4 times 4?
16.
And what's 16 times 4?
60.
That's right. You can double check that math using mental math. 4 times 10 is 40. 4 times 6 is 24. Add 40 and 24 together to get 64. Now, how many decimal places should I have? 3. Yes, it looked like there was one up here, but it repeats 3 times, doesn't it? So there's going to be 3, which means I need to put my decimal at the behind the 4 and count over 1, 2, 3, and that blank spot is going to have a 0 in it. So 0.064. How many negatives do I have? 3. 2 negatives make a positive. 3 negatives back to negative. So it should be negative 0.064. Questions? Let's move on to the more time-consuming part of tonight's lesson and homework, which is the dividing decimals. You're not going to like dividing decimals as much because it requires long division. Okay. Now, you may not like long division, but I know you know how to do it. Okay. So we're going to set up long division, and just a reminder, the first number goes inside the division box. Last week, you heard me say that the top dog gets the house. Well, they're probably not going to write it like this. We don't typically put decimals inside of a fraction, right? You could write it like that. I mean, it really is a division sign, but you probably won't see it like that. So instead of saying top dog gets the house, we can just say first dog gets this. Whatever the first number is, that's our dividend. It's going inside the box. The number we're dividing by, always the second number, goes outside. Now, what's interesting about that outside number is that I want to move the decimal point so that it's not a decimal. I do not want the outside number to have a decimal point. I've never done long division like that. You've had decimal points that are in the problem. Like, for example, I guess they can't see me over here. I better write it over here. You've seen problems where, for example, let's say I was doing 19 divided by 40. 40 doesn't go into 19, obviously, so I go like this. And since 40 doesn't go into 19, what do I put? Yeah, but a decimal point, yeah, I put decimal points inside the box all the time. But the number outside the decimal, the box is never a decimal. I don't want it to be. So if it is, I want you to slide that decimal over until it's a whole number. That could be 1 times or 2 times or 3 times. Then, because I don't want to change the problem, that's legal to do as long as you move the inside decimal point the same number of times. You can't move the outside 1 spot and then move the inside decimal 2 spots. You can't do that. But you can move them both 1 or both 2. Then we're going to divide like normal and count our negatives. Let's look at the first problem here. Is my answer positive or negative? Positive. Ignore the negatives then. It's positive. Don't worry about it. Put 12.56 inside the division box. Put 0.8 outside the division box. I know it's positive. Let's slide this down just a little bit. I don't want the outside number, my divisor, my second number, to be a decimal. So how many times would I need to slide the decimal point over, Maddie? 1 time. Now I'm just dividing by 8. Have you divided by 8 before? Of course you have. Yeah. In order to do that, I also have to slide the inside decimal point over 1 spot to make it 125.6, and just go ahead and float it while you're over there, float it right up to the top. Now, instead of doing 12.56 divided by 0.8, I'm doing 125.6 divided by the whole number, 8, which I've done before. How many times does 8 go into 1? Doesn't? Okay. How many times does 8 go into 12? Put the 1 above the 2 then in the 12, because it didn't go into 1, but it went into 12. So put it above the 2, and we're going to subtract. And 12 minus 8 is what? 4. Drop down the next digit. How many times does 8 go into 45? Okay. What is 8 times 5? Okay. Subtract. 45 minus 40 is 5. Drop down the next number. Because I'm not done until I get a 0. How many times does 8 go into 56? What is 8 times 7? Well, it looks like I'm going to get my 0 right there. So I'm done. And we know it's positive, and we know it's 15.7. Once I slide the decimal point over on the outside and then also on the inside, this is just like any other long division problem I've done. Doesn't mean I like it, but it doesn't mean you can't do it. Example B, the first number goes inside the division box, 8.722, divided by 3.56. Now, I didn't write the negative there because I know that if I have 1 negative, my entire answer is negative. So just put it right there where you're going to write your answer. Then you don't have to worry about writing it as part of the problem. How many decimal places does the outside number have? 2. Slide it over twice. That means I need to slide the inside decimal point how many times? Twice. Right between those 2's, float it up to the top. Now, this one's not going to be really fun to do. 356, sheesh. It doesn't go into 8. Doesn't go into 87. How many times will it go into 872 if you had to guess? Twice. Okay, so 356 times 2. We're going to check that. I agree, it's probably twice, but we need to know what that is. 2 times 6 is 12. 2 times 5 is 10, plus 1 is 11. 2 times 3 is 6, plus 1 is 7. Yeah, we're not fitting another 56 in there. So I'm going to put the 2 right above the other 2 because I didn't go into 8 and I didn't go into 87. I went into 872. So it's got to go above that 2. Subtract away the 712. What's 2 minus 2? 7 minus 1. And 8 minus 7. Okay. Drop down to 2. What's your guess as to how many times 356 goes into 1,602? 4? I heard 4 first. I can try 5 here in a second. I'll try them both actually. Four times 6 is 24. 4 times 5 is 20 plus 2. What's 4 times 3? Plus 2? I don't think we're going to fit another 356 inside that, right? So I think, yeah, this is going to be 4. I'm going to put the 1,424 right below, and I'm going to subtract, which means I'm going to have to borrow. Can't borrow. I can't do 2 minus 4. I can't borrow from the 0. I got to borrow from the 6 to make it a 5. This becomes a 10, which then I borrow to make it a 9. This becomes a 12. What's 12 minus 4? 9 minus 2. 5 minus 4. 1, and then 1 minus 1, 0. So I ran out of digits. So I've already got a decimal point, and I've always just added zeros and dropped them down until I get 0 for my remainder. Now it's going to go in more than 4 times. Never erase your side work. Never erase it. Even if it's wrong, you might need it later on in the problem. So don't erase it. I mean, I'm not going to erase the 4 because I know that it's going to be more than 4. It's probably going to be 5. Let's see what 356 times 5 is. What's 5 times 6? 5 times 5? 25 plus 3. 5 times 3 plus 2. Look at that. 5 is going to go right there. I subtract and I get my remainder of 0. My answer, and I might need to scooch the negative over a little bit, is negative 2.45. Negative 2.45. Let's do one more. That way you guys can say you beat period 1. What's the first number? 8 goes inside the box. What's the second number? Okay. Is my answer positive or negative? Yep, there's one negative, so it's gonna be negative. So that part's taken care of. The outside number has 1 decimal point. So I'm gonna slide it over 1 time, but where's the decimal point on the 8? Aiden? At the end of it, yeah. So I put it at the end to make it 8 point nothing. And I'm gonna slide it over 1 spot. And what am I gonna put in that 1 spot? A 0. Yeah, instead of doing 8 divided by 2.2, I'm just gonna do 80 divided by 22. Float this decimal up to the top. 22 doesn't go into 8. It does go into 80. Any guesses? 22 times 4 is 88. That's too big. How about 22 times 3? 66. That's going to do it. Okay. I'm not going to erase my side work just because it's wrong though. So I'll put the 3 right there. 66. What's 80 minus 66? 14. Yeah. Drop down to 0. Guesses as to how many times 22 goes into 140? 6 times. 6 times 2 is 12. Carry the 1. 6 times 2 is 12. Plus 1 is 13. So yeah, I agree. We'll put the 6 right there. This is 132. Subtract. I'm going to get 8 because 32 is 8 away from 40. I'm going to drop down to 0. Didn't I already do 22 into 80? How many times did it go into 80? 3 times. And that's going to give me 66. And guess what's going to happen? It's just going to keep repeating. Yeah, if I can do this right. That was 14. Drop down to 0. Yeah, it's just going to keep repeating. So the 6 and the 3 are going to keep repeating. And so I'm going to put negative 3.63 with a repeating bar over both of them because it's going to keep going 63, 63, 63, 63. And I think we got time for this last one. First number, 1.11 or 1 and 1100ths. I said it the long way. Divided by 15. Is my answer going to be positive or negative? Negative. Good, because I got 1 negative. How many decimal places does the outside number have? None. Yeah, I don't have to move the decimal at all, actually. Right? It has no decimal places, so I don't need to move the outside one, so I'm not going to move the inside one. Any guesses as to how many? No, it's not going to go into 1. It's not going to go into 11. By the way, since it doesn't go into 11, I have to put something here. So how many times did it go into 11? 0. You have to put something there. I can't just leave that blank because it's an actual decimal place. So I'm going into 111. 15 goes into 111. How many times do you want to guess? 9. Okay. 9 times 5 is 45. 9 times 1 is 9 plus 4 is 13. So it's a little big. I'll leave it there. We might need it later. 15 times 6. 6 times 5 is 30. 6 times 1 plus 3 is 90. I bet we can fit another one in there. 15 times 7. What's 7 times 5? 7 times 1 plus 3. I think that's it. So it's going to be 7 right there. I need a better job of lining up my digits. There we go. That was 105. 11 is how far away from 5? Drop down to 0. Any guesses as to how many times 15 goes into 60? 4. 15 times 4 is 20. Or 5 times 4 is 20. Carry the 2. 4 times 1 is 4 plus 2 is 6. Yeah, that's going to work. So that'll give us a remainder of 0. and negative 0.075 as our answer. And that is how you divide decimals. Not fun. What's wrong? What I put? What in the world did I do? Yeah, I don't know why. I clearly had 4 right there, didn't I? Yeah, so I should put a 4 right there. Thank you for catching that, not just drifting off to sleep. Okay, negative 0.074 is your answer. Where can you find tonight's homework?
Oh,
No, that's where you find the notes. Big ideas. And do you need a work paper for this?
Yes, ma'am.
Always, excuse me?
Yes, sir.
Thank you. Always need a work paper. Okay, and you got plenty of work to show on this one. You guys are dismissed.
Miller,